Column chromatography operates on the same principle that all chromatography operates on, and that is the interaction between solute and stationary phase and the solute in the mobile phase. In column chromatography, however, different from thin layer chromatography, the solute is loaded onto a top of a column. Inside this column we have our solid stationary phase, and the solute moves down the column. So TLC, the solid moves up, and spots move up. In column chromatography, all of our solute moves down. So we put our mobile phase with a pipette in the top and it drips out down in the bottom. Now, column chromatography is used quite extensively in biochemistry. It's used to separate proteins. Specifically, some types of chromatography that you're going to see if you go on and take biochemistry is size exclusion chromatography, affinity chromatography, and cation exchange chromatography. So here we have our two compounds A and B. They're on the top of our column now. Now we're going to add our mobile phase. As that mobile phase, in this case hexane for example, comes through our column, the components of our mixture that have similar intermolecular forces to hexane, right, the nonpolar solutes, are going to pull off of that stationary phase and move faster with the solvent. The compounds that are more polar will bind and adhere stronger to the stationary phase. So here's an example. We're loading our sample here. We have a purple sample that's a mixture of our blue and red A and B, and we're adding our solvent. And as we start to have our solvent elute out of the bottom of our column, the spots begin to separate. So we have a blue up at the top, purple where they still overlap, and red moving down out of the bottom. And we continue to add our solvent. And as we do that, the two compounds begin to separate a little bit more from each other, right? That distance grows a little bit more. And finally, we get close enough where we start collecting various fractions of our red compound that's eluting, right? And hopefully we have a number of test tubes between the red and the blue, which we don't have any solute being eluted. And then we collect our blue, and then we're done, right? So in this experiment, you would pool together these three, right, red ones, and you'd evaporate them down to a concentrated form and analyze them, and you'd collect these three. Now we wouldn't want to have this be purple because then we wouldn't have good separation between them, right? If this test tube here in the middle was purple, it would mean that there's an overlap of our elution, and we would try to find a good solvent, our stationary phase, to separate that distance a little bit so that we could get a better purification.